Hello once again. In this video we'll be talking about how to factor polynomials, and we're going to go back over some, old methods that we've used in the past to factor polynomials, as well as show you some new ones. Again, if you haven't already checked out the factoring review video, I'd suggest you go ahead and do that, because if you don't know how to factor in that video, or then you're going to have to struggle with this one. So please go back and review that if you have any issues factoring. Okay? Alright, so let's look at this one. Many of these, we're going to try a couple things. Now, the very first thing you always want to do in factoring is look for a GCF. Is there a greatest common factor? Meaning, do all four terms, in this case, but however many terms there are, do all of them have something that they can all be divided by? And in this case, there's not. Not every single term is divisible by a number, because you got 1x to the third and negative 1x squared and 25x and all that stuff. But also, not every term has an x either, because the very last term doesn't have an x. So there's nothing that all four terms have in common, so there is no GCF here. Alright, so what we're going to do is, with these four terms, we're going to try factor by grouping. Whenever you have four terms, you should try factor by grouping. Alright, so let's go ahead and do that then. I'm going to go ahead and rewrite this problem. Because why not, and then group from there. So when you factor by grouping, you always group the first two terms together and the last two terms together. There's a little bit of a catch with this one. You can probably see what I've done here is, notice the negative 25, it's minus 25. I'm including that negative sign in my parentheses as part of that term. I put a little plus sign here between them because, well, if I'm putting the minus sign with that second group, I need something to separate these two, and plus sign will work for me. Alright, so without further ado, go ahead and let's GCF these two groups. So my first group, my x to the third minus x squared, what do these two terms have in common that I can take out of them? Well, they both have at least two x's, right? An x squared. So I'm going to take out an x squared from both of these. They each have two x's. I will factor those x's out. So the x squared will come outside of the parentheses, and then we'll see what's left of each term. The first term had three x's. I've taken two away, which means there's going to be one x left of it. And then x squared minus x, or divided by an x squared, these all cancel out, so there's no more x's. And I'm just going to be left with 1, because a negative 1 divided by a 1 is still a 1. Okay? That's the first group. The second group, these are pretty simple, pretty obvious. These are both divisible by 25. However, whenever you got this negative brought inside the parentheses, you should probably factor it out as well. So let's factor both of these by negative 25. Let's take this negative 25 and bring it out in the front of this group and see what's left. Negative 25 divided by negative 25 will just be a positive 1x. And then positive 25 divided by negative 25 will be a negative 1. So when you factor by grouping, something should happen every single time you factor your two groups if factor by grouping works. And that is a common binomial factor. You'll notice these two groups both have an x minus 1 now. So that x minus 1 factors out. We can take the x minus 1 out of both groups and set that aside. And then we'll see what's remaining. Well, what's remaining without those x minus 1s is x squared minus 25, and that will make up my next group, x squared minus 25. Now, I factored by grouping, but you can't always assume that just because you factored that much, that's all the factoring there is to do, because that is not the case in many problems, and it's not the case here. I factored by grouping, well done me, but look at my answer, x minus 1 and x squared minus 25, and see if there's any more that you can factor. You might notice, or you should notice, that the x squared minus 25, that's a difference of squares. Okay? We've already talked about what the difference of squares is, but just a reminder, a difference of squares, and I'm just going to read the list for now, states that if you have a squared minus b squared, right, a difference of two squares, that equals same as a plus b, a minus b. Alright? So here I've got two squares, I've got x being squared, and then 25 is a result of 5 squared. So that means this difference of squares would result in x plus 5, x minus 5. So if I put everything together, my final answer, I have that x minus 1 from before, but when I factor my difference of squares, I also have x plus 5 and x minus 5 as an also additional result. Alright, so let's try another one, and if you want to try and do it without me, you can certainly pause the video first and try it on your own. Alright? But if you're not, then let's go ahead and not waste any time. This again, let's try, because there are 4 terms, let's try the difference of squares approach. Or not difference of squares, I'm saying. The factor by grouping approach. Alright? So I'm going to group these first 2 terms together. And I'm going to group these last 2 terms together. And again, since I have a minus sign for that 9x, I'm going to make sure that's included in that second group. And now we'll see what these groups have in common that I can GCF out of each of them. So in the first group, both of these 2 terms, x to the third and negative 2x squared, they both have some x's in common. Both terms have x's. And how many do they each have at least? Well, they each have at least 2 x's, so I'm going to go ahead and take that out of each of these. So we'll factor out the x squared, and now we'll see what's remaining. With the first term, x to the third divided by x to the second means that there's a single x remaining there. And then for the second term, the x squareds cancel, and we're left with the minus 2. Alright, and now in the second group, well, both of these are divisible by 9. However, because we have that negative with that first term, and I want to get rid of this negative, let's go ahead and divide by a negative 9 rather than a positive 9. Alright, both terms can be divided by a negative 9. So let's bring that negative 9, factor it out. I'll see what's left. And the first term, negative 9 divided by negative 9 will be 1x. So the negative is no longer part of that term, the negative is on the outside. That's why I divided by negative 9, not positive 9. And the second term, 18 divided by negative 9 is a negative 2. Now remember, every time you factor by grouping, you just have a common binomial factor. And you'll see that these 2 groups both have an x minus 2. So what you're going to do, and I'm going to put this off to the side here, is factor that x minus 2 out. Right, that x minus 2 can be set aside, taken away from each of these groups, and now we see what's remaining without the x minus 2. Well, what's left without the x minus 2's? X squared and minus 9. So that makes up my second group. However, just like the last problem, don't assume you're done factoring just because you factored once. There is more to do here. The second group here, just like the last one, this is another difference of squares. So we're going to factor that by difference of squares again. Alright, the x minus 2 is already factored enough. That's not going to change. However, the x squared minus 9. X squared is clearly x squared. And the 9 is a 3 squared. Right? So that makes up, when I put these together, we follow the format of difference of squares. This would be x plus 3 and x minus 3. Okay? Again, that is based on the rule of difference of squares that I wrote down in the last slide. I'll go ahead and write it down. Again, is that you would have your a squared minus b squared is equal to your a plus b and a minus b. Alright? This would be my a, this would be my b. Okay? Either way, that is fully factored now. Alright. So, let's move on again now, shall we? See what else we have in store for us. I'll leave this one for you guys. It does the same thing. Alright, however, there's some new rules that we need to talk about. We know we're already aware of the difference of squares method, or difference of squares factoring. You know, that's if you have a squared minus b squared, I guess we don't really need a little parenthesis. That this would be equal to having a plus b, a minus b. An example of that we just looked at with x squared minus 9 was this would become x plus 3 and x minus 3. Okay? Alright, because that is, of course, and if you see it in another light, x squared minus 3 squared. Oops. Well, I mean, hit the button, but it Alright, we'll just come back to it. With that separation, I think. Alright, but here's some new rules, some new methods that we need to kind of memorize. And yes, memorizing is going to be key here, but it's not much to memorize, I don't think. You just kind of have to remember where the plus and minuses go. Alright, but sum of two cubes. A to the third plus b to the third. So you have two, gosh darn it, two cubes. A to the third, b to the third, whatever, something to the third power. It would factor into this form. Same thing if you have the difference of two cubes, the difference being the minus sign, it would factor into this form. So they look very similar, but there's some subtle changes, and there's based on the plus and minus sign. And there's the first one, the sum of two cubes. The first pair is a plus sign. However, the second group has a minus and then plus. Whereas the difference of two cubes, the only difference is the difference starts with the minus sign. And then the other group has both plus signs in it. So it's really kind of a matter of knowing the difference in those signs. But let's take a look at an example of this real quick. Let's look at let me just make one up. If we have, say, x to the third power minus, what's a perfect cube? 27. Alright, notice this would be a difference of two cubes because it's minus 27 instead of plus 27. So if we use our outline right here, alright, notice x to the third power is, of course, x to the third power. So x is going to act as my quote-unquote a value. And then 27 is 3 to the third power. So this 3 will act as my b value. Okay? So I'll just label them so you can see how they're going to be defined in here. So I'm going to go ahead and just put this right below it so that you can see how everything's lined up. I'm just going to use this as a template. Alright, so I've got x to the third power minus 3 to the third power. Right? So essentially x is my a and 3 is my b. So I'll just go to put x where a is and 3 where b is. So a minus b, a is my x, minus 3, which is my b. And then a squared, well, a is my x, so that means it'll be x squared plus a and b, that's x and 3. So I'm going to put 3x instead of x3, so it's a little bit backwards, but the same thing. Looks better. And then plus b to the second power, b squared. b is 3, so that'll be 3 to the second power. Alright, that's it, but now, of course, there's just a little simplifying. I mean, I could write that 3 to the second power as 9, so really what this will look like is x minus 3, and then x squared plus 3x plus 9. So that's how this would factor. It would look like this. It's definitely a little different, definitely a little weird. We got to get used to these formats. That's going to be the thing. We're just going to have to, at least for the first few times, maybe just kind of use that template and change it before we get to memorizing it. Alright, but before we do that, let's look at this example. Now, just like any other GCF, it doesn't matter if I just introduce a new method or not, or I'm sorry, any other factoring kind of spoils it there. You always want to check for a GCF first. Regardless of any other method, you should always look for a GCF first. Now, in this one, these two terms do have a GCF, they do have something in common. Both of them, not only do they have an x in common, but both of them are divisible by 4 as well. So we're going to divide 4x out of these two terms. Alright? So the 4x will come out, which will leave the first term, since the 4 is gone, and I've taken the next way, which is x to the third. And the second term, 108 divided by 4, the x's will cancel. So 108 divided by 4 is 27. Alright, so I factor the GCF. You might think we're done if we factor the GCF, but x to the third plus 27, this is a sum of two cubes. So it's probably helpful to memorize what perfect cubes are before we factor this. Let's go ahead and make a list of perfect cubes, shall we? And then we'll come back to factoring. Because how are you going to recognize that that's perfect cubes, right? Unless you have something to go by. So perfect cubes. Let me erase this so it's kind of out of my way. We'll put it back here later. Perfect cubes. Well, let's start with variables. Variables are pretty easy. So perfect cube variables would be x to the third, x to the sixth, x to the ninth, x to the 12th, x to the 15th. You can probably see the pattern there. All these are going up by 3, right? Those are perfect cubes in terms of your variables because of the types of exponents they are. X to the 4th is not a perfect cube, okay? Only these are, and of course, any succeeding one going by 3 for the exponent. So the reason is because x to the 3rd is equivalent to x to the 3rd power, of course. X to the 6th is equivalent to x squared to the 3rd power. X to the 9th is equivalent to x to the 3rd to the 3rd power. X to the 12th is equivalent to x to the 4th to the 3rd power. And you can kind of see where this is going. X to the 15th equivalent to x to the 5th to the 3rd power. So these are all perfect cubes because all of these can be raised to the 3rd power. All right. So in short, just kind of remember that if the exponent is divisible by 3, it is going to be a perfect cube. What about numbers? I would keep this on the same paper as well. Just like have enough room to write it. So, what about numbers? Numbers. So, perfect cube numbers. 1 is a perfect cube. 8 is a perfect cube. 27 is a perfect cube. 64 and 125. There's plenty more. But these are perfect cubes. And why is that? Because 1 is, of course, 1 to the 3rd power, or 1 cube. 8 is 2 to the 3rd power. 27 is 3 to the 3rd power. 64 is 4 to the 3rd power. 125 is 5 to the 3rd power. So you can see how we get about these. You do 6 to the 3rd power, 7 to the 3rd power. Those results would, of course, be perfect cube as well. But in short, try to memorize at least this list. Notice, of course, x to the 3rd, as we mentioned, is a perfect cube. And 27, as we just mentioned, is also a perfect cube, which is how I can know that this is a sum of 2 cubes. Alright, sum obviously because it's plus as well. Alright, so I'll just kind of erase what we got here because I think rewriting will just be easier. So remember what we did. We saw GCF, both of these were divisible by 4x. We factored out the 4x. And we got x to the 3rd plus 27. We recognize that x to the 3rd plus 27 is a sum of 2 cubes. Now, the sum of 2 cubes rule that we saw on the previous slide says that, I guess it was a, right? A to the 3rd plus b to the 3rd is equal to a plus b, and then a to the 2nd minus ab plus b to the 2nd. That is our rule. So here, x to the 3rd plus 27. This is the same as x to the 3rd, so essentially x is like my a value, plus 27 is 3 to the 3rd. So 3 will act as my b value. So just using my template now, this would become a being x, b being 3. So everywhere I see a, I'm just going to put x. Everywhere I see b, I'm going to put 3. So it'd be x squared minus, or sorry, yeah, it is minus. I almost put plus sign. Minus 3x plus b to the 2nd, which would be 3 to the 2nd. I'm just going to go ahead so that you know how I did that. 3 to the 2nd is 9. I'm just going to go from the right to 9. I'm going to write this down again. Okay? And so this would factor completely into 4x, x plus 3, x squared minus 3x plus 9. That's how this would fully factor. Alright, looks kind of crazy, but that is fully factored. Okay, you just kind of have to know these rules: the sum of 2 cubes and the difference of 2 cubes as well. Use them as templates until you get used to it and can start, I guess, memorizing it. So there's the results. Alright, I'm going to cut this video off here. I will go ahead and show you the next few examples so that you can see them. I guess this is probably big enough. And you can see how they're all used. Okay? You can pause the screen and look at them. But I'm not going to work them all out now. I've already explained how to do it. But here's just those few examples. Alright? I will leave it at that. We'll see you in the next one, guys. Later.